So I'm Huan. I publish on the Jun, but you can call me Luke if you want. So today I'm going to talk about our recent study on transparent predictive analytics. I'll give a quick introduction, and then I'll talk about a theory called human constructivism learning. And then we'll talk about our formalization using Bayesian nonparametrics to support human constructivism learning. Then present some experiment study, and we conclude from there. So I guess you don't need me to emphasize the importance of safe data analytics. I know at the KDD conference we are, especially this morning and also the previous talks, we are heard many talks related to this concept. So basically related to fairness, transparency, interpretability. And there are many, at least 2 White House reports emphasize the concept. And also the concept is universal. EU recently passed a regularization, which is binding, requiring that the individuals to receive meaningful information about logistics behind algorithmic decision making. And I see, and also there are many discussions on these topics now. So if we look at this concept of transparency and interpretability, it's actually a pretty complicated concept. It's definitely subjective and usually context dependent. It's not just a single concept. It may be defined at multiple levels. And also there's a discussion about what's the relationship between transparency and interpretability. People argue that those two are completely different concepts. Other people treat them interchangeably. So in the following talk, we do not try to differentiate these two concepts. We just put them together. The reason is that we don't feel that there is sufficient evidence now to separate them. So among the many case studies that demonstrated the importance of transparency and interpretability, I just find this case study done Corona, published the KDD 2 years ago. That's the best one I found so far. So what they did is that they look at the electronic health record. They're trying to build a model to predict the risk of death caused by pneumonia. So that's just a typical machine learning data mining predictive analytics task. I have data, I have an endpoint, and the data labeled. I try to make a prediction. Pretty straightforward. And what they discovered is that there's actually a very simple rule saying that if the patient had asthma before, the risk of pneumonia caused death is actually low, which is counterintuitive. Absolutely doesn't make any sense. If the patient has asthma before, that actually lower the risk of death. So, however, on the other side, if you look at the data, according to their study, the pattern is very clear. If you use this rule, actually, the prediction power is very strong. So what's going on? And then they did a study. They showed that most of the patients, when they have pneumonia, will be admitted through intensive care unit, ICU. And as a routine in the ICU, the physician will ask the patient whether they had asthma before. And if the answer is yes, the physician will order intensive care. And because of the intensive care, the patient actually has lower risk of pneumonia caused death. So that's great. That's actually great. And there are a couple of comments observations I want to draw upon this case study. One is that if you think from patient perspective, if you think about this rule, if having pneumonia then lower the risk, that's actually actionable. Whether it's causal or not, I don't know, but it's definitely actionable. So I'm not arguing, or I'm not advocating for this, but for example, let's say hypothetical case. I have pneumonia, I get admitted to ICU. And I know that if I tell the physician I had asthma before, the physician is going to order intensive care, and then I'll have lower risk of death. Okay, so again, I'm not advocating for you telling lies, no matter whether you have asthma. But if hypothetically, let's think about the case. So this rule is definitely actionable, and we can expect that if you follow this rule, you actually can lower your death risk. But from physician's perspective, it's disaster. Right. So if let's say we have a young physician, of course, I believe that our physician, if they are well trained, of course they won't follow these rules on the surface, right? But if let's just hypothetically, this is a young physician, and this physician somehow get a dual training in both machine learning and medicine, and the physician actually could accept the concept of big data. So in the name of big data, right, we do be able to make predictions, very strong prediction. And the physician look at the patient and say, okay, you have the asthma, and my big data tells me that you have low risk. So I can put you aside. I don't need to worry about you. I think that's definitely a disaster. Right? And of course, in US, the physicians are well trained, so that that probably won't happen. But if we think about this, if we have a system, we have system look at the electronic health record, and we use deep learning, a very fancy tool, and we find build very accurate models. And we're trying to use this model outside the US. What will happen? So the physician will look at the patient, say this is a cutting edge, latest technology from US tell me that the patient has a low risk. Okay, so of course this is very I push this to the extreme case. It probably won't happen in reality. It doesn't say that when you go to ICU, if you have pneumonia, you should tell the physician you have asthma, no matter whether you have asthma before. Okay, so what I want to do is that I want to draw upon this case study. I want to argue that when we think about transparency and interpretability, we should look at the whole pipeline of modeling. We should look at how the data collected, how the data is pre-processed. We should look at how do we derive the model, what the model is doing, and what does it mean to the end user. We should involve data scientists. We should also involve domain experts, potentially. But that sounded like a very complicated process. That sounded like, so there's definitely a lot of work trying to build the predictive models that are interpretable and transparent. So for example, super sparse linear models, generalized additive models, interpretable decision set. And we actually have a tutorial on safe predictive data analytics. We reviewed many related work. That happened Sunday. So if you're interested, feel free to check back our website and release slides. So what we did on this subject is that we borrowed the idea from human learning. This is a theory called human constructivism learning. That's a philosophical view about how human learns. It's basically epistemology, but it actually influenced the education system significantly. So what is this theory? What is this human constructivism learning? So basically, the theory tells, according to the theory, that basically human learns by interacting with the external world. So there's infinity exposure to the external world. And during these interactions, there are two fundamental processes. One is something called assimilation, another one is called accommodation. So what does that mean? So basically, when we have a new piece of interaction with the external world, we have a new experience, human usually check whether there's something we see before. If we had a similar experience before, then we use this new experience to update our existing framework. And if there's something completely new, we never had the experience before, human has this high-level intelligence, recognizes there's something new I never saw before. Therefore, I realized consciously that I needed to create a new task for it. So this is called accommodation. And let me give you an example of what happened. So let's look at the right part, right lower part of this image, we see basically simulate a human brain. And then let's suppose this person already see many pictures of dog. So now we have an image of dog, and what happens is that the person will use the image to update the knowledge of a dog. Okay, so that's called assimilation. And then we see another image of dog. Then we see another one. And we see another one. So what happened? Should we continue to update our knowledge about dog? Yeah? Yes? Yeah?
We can stop at some point once we got it right.
We have to, in this case, we have to realize there's something new here. Yeah, yes, exactly. Well, Canadian people are very probably familiar with that. I don't know whether you're Canadian, but thank you for pointing out that. So I think the point I was trying to make is that we should stop and realize there's something new. And that we have a new task that's called wolf. Okay, so that's called accommodation. The previous is called assimilation, and that's called accommodation. And now let's put the whole thing into a machine learning, data mining, and predictive analytics framework. So what does that mean? That we have a new training instance. According to this constructivism learning, you basically need to make two decisions. Maybe you need one decision, is that whether you assign to an existing learning task, so that you are using the new training instance to update the existing task, or you create a new training task. Okay? This is sequential learning, online learning, and every time the human intelligence, high-level intelligence, is this something new, or this is something I saw before. If we put that into that context, then people say, "Oh gosh, this is what we are familiar with. This is basically directly the process mixture model in a supervised learning framework." So what is this dirichlet process mixture model? It's basically, so I hope this will work. Okay, so basically it's a nonparametric model. G is a distribution of distributions. So the instance, the sample from G is a set of distributions. And this is controlled by two parameters, alpha and G0. G0 is a base distribution, and alpha is a